No, never said that. All right, 9.3, functions. So yesterday you learned about relations. And relations, remember, just your x and your y. Remember? Relations only have an x and y, not just an x or an x, y, z. All right, a function, a relation in which no two ordered pairs, which is an x and a y, have the same first coordinate. Okay, so what's the first coordinate?
X.
That's right. They do not have the same x coordinate. Very good. I'm going to put another star here, and I'm going to underline this. Notice they didn't say y, they just said x. So a function is a relation in which no two ordered pairs have the same x. So if there are two ordered pairs and they have both of the x's are the same, then it is not a function. But if all the x's are different and they're all relations, they're all perfect ordered pairs, then it is a function. That may be a little confusing, so I'm going to give you an example. I'm going to call this function, this set here, f. It can be called g, h, or anything else, but I'm going to call it f right now. And I'm going to give you a set of ordered pairs. And let y'all write them. Let y'all catch up a little bit. Taylor, you caught up? Yeah. All right. I'll wait for others to finish. You got it, Cecilia? Mm-hmm. All right. Everyone good? Okay. So let's look. Is this above, these ordered pairs, see all these ordered pairs? Mm-hmm. Is this a function?
No.
Why not?
Because it doesn't have the same x.
Ah. It is a function where no two ordered pairs have the same x. They do not have the same x. Or let's look at the x's. Are any of these the same?
No.
Then it is a function.
Oh.
That's why I said it's confusing. It's probably my fault too. I'm not very good at explaining things. It's a function if all the x's are different.
Overall different.
Yeah. That's why I said, I'm not good at really explaining things sometimes. That's my fault. And so that's why I like doing lots of examples. So now does this help? It is a function if all the, I should say that. It's a function if all the x's are different. There. That would be better.
Wait, can you say it again?
Let's see. It's a function if all of the x's are different. There, that's better. Okay. So it is a function if all the x's are different. Okay, Michaela? Okay. All right. So no repeating x's. Does that make sense?
Yes.
Are we good?
Yes.
All right, so it's a function if we don't have the same x's. Now, you can have the same y's. Like notice right here, this 3 and this 3, you know how it has the same y? That's okay. It's just the x that you got to remember. Okay, Taylor? Yes.
So if the x had the same, then it would not be a function.
Correct. Good one. Yes. If we had same x's up here, like if we had -3 and a -3, it would not be a function.
Okay. You go.
Okay. So if like two of them have the same x's, the whole
Thing is not a function.
Okay.
That's right. Go ahead, Whit. Y'all are so polite. I love this class.
And if it had the same, would it be a relation?
Okay, so that's a good question too, guys. So if you look at this, are these all normal order pairs?
Yes.
Yes.
Then it is a relation. In fact, I'm going to write that.
What would not be normal?
Like if it just had a 3.
Oh.
Or if it had, and I'm going to write this in red, so don't write it down, but if it had like this, that's 3 numbers. If it was like Minecraft coordinates with an X and a Y and a Z, that would make it not a relation.
So
Z is forward and backward, right?
Okay, we're moving too far. Okay. Okay, what your hand is not up, like Michaela. Thank you, Michaela.
can a function be a what's that word that starts with an R?
Okay, it is a relation.
Oh.
So a function is a relation. So it has to be all ordered pairs, but it cannot have the same x.
Okay.
So a function is a relation. All right? Because so it can't have 3 numbers or something, and it can't have the same x. Taylor.
Is there something where it's like a function except with the y coordinates?
No. Y'all are starting to sound like Algebra 1. Y'all start going off in all these different directions with y'all's questions, and I love it. It just, oh my gosh, sometimes I can't answer them. All right, so we're going to go ahead and list our domains. Do y'all remember that from yesterday?
Yep.
All right, so we write them from least to greatest. And no, I will not take off for that, but we need to get in the habit. So let's look at our x's. And Cecilia, what would be my first one? Oh, look at her go. What would be my next one, Izzy? Good. Emily? Good. Aiden?
3.
Good. Let's see, Michael?
4.
That's right. See, I call on y'all randomly to keep y'all awake.
I love how it was already just.
In order.
Yeah.
Okay, so now I'm going to list my range. And remember, domain is your x and your range is your y. Okay, so let's see. Who's my first victim? Taylor.
-2.
Oop.
Wait, sorry. -3.
Good. Gabby. Good. Whit.
3.
Good. And Cecilia again. Good. So basically, both of these, this whole thing, is a relation because they are ordered pairs and a function. And I know that it's confusing, but we're going to practice this. It gets easier, believe it or not. And I think it was this class that said this wasn't even normal math, right? Isn't that what y'all were saying, Emily?
Hey, can I sharpen my pencil?
Oh, please hurry, Taylor. We'll give people time to copy this down. Move it, pep in your step, buddy boy. We're behind because of the silly drill, which isn't silly, by the way. It saves lives. Why would it? I'm going to draw the silhouette of Taylor's head since he's in the middle of my screen.
Nobody should. Taylor, stand still.
I'm poking your head, Taylor. Hurry, Taylor.
Taylor.
It's a pencil fight. Okay, here we go. Example. Let's do another. Joanne's going to watch this video and just laugh and laugh.
Oh, I forgot that she was missing.
Well, that's not rude.
Okay, I didn't realize. I wasn't trying to.
Well, it has been kind of a crazy morning
With that silly life
with that silly life-saving drill. Okay, so we have 4 ordered pairs.
I have a question.
No questions allowed.
No questions asked.
Is this a function? Don't answer out loud. Do not answer out loud. I'll wait till everyone has this down. But I want you to think about it. Don't answer out loud or I give a conduct mark. And y'all are going to stop doing that in her class too, by the way. I told her to start giving out conduct marks every time people yell out answers, by the way. That's, no. Okay, give everyone a chance. Okay, so remember, these are your ordered pairs. So, is this a function?
No.
You're correct. It is not
Why did you sound surprised whenever you said that it's not?
a function. Okay, if you notice, there's a 3 as an x and another 3 as an x. 3 in x spot is repeating. So therefore, it is not a function. Does that make sense, guys? Is this a relation? Raise your hand. Taylor?
Yeah.
Yes, it is. Because they are all X and Y ordered pairs.
Is it possible for one pair to not be X and Y?
Not right now.
Isn't pair 2?
Okay, shh. Exactly. Very good. All right. Does everyone have this down? Okay, take your time. Take your time. Remember, this is our week of no Spanish. No Spanish. So if we have to dip into study hall, we can.
Dip our feet in this thing.
Can you see, Izzy? You got it? All right. Let's turn the page. Okay, now when doing functions, and I've only once, when I first started teaching Algebra 1 and PreAlgebra many, many moons ago, I had a student asked me why and what I'm about to show you, an actual explanation. I taught both Algebra 1 and Pre-Algebra an explanation as to why what I'm about to show you is the way it is. Nobody cared. Nobody cared, and I wasted my time. I mean, they're like, what? That whole blah, 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 blah. So we're just going to say this is the way it is and not waste our time. When you're writing a function, it's going to look something like this. Sometimes it's going to look like this. Sometimes it's going to look like this. There could be all kinds of letters, to be honest. I've seen, but they won't ever be X and Y. I've seen the weirdest of letters, but typically it's going to be an F and a G there.
Was there ever a pi symbol?
No. Whoops. Hold on. This is how a function is written. Every time you see that, you'll know you're dealing with functions. And by the way, f of, and this is how I'm going to say it, f of x or g of x sort of means y. It behaves the exact same way. There's a better, more professional, and accurate explanation, but my 7th graders understand it better if I just say it represents y in a function. Because you see, they're saying that this is the x, and we're looking for y. Oh, that's just going to confuse you more. So I'm going to be giving you some more examples, because explaining it is very difficult. Yes, Taylor?
Mandalorian explaining functions be like, this is the way.
Yes, this is the way. All right. Let's do another example. All right, let's say you're given, this is what you're given, like in your book. F of x, so we know it's a function, equals 2x plus 4. That's your equation. It's basically like saying y equals 2x plus 4. So don't freak out when you see the f of x or g of x, because it's really kind of like saying this right here, like a linear function. You're looking for y using random.
Is that 2x or 2x plus 4 or minus?
That's plus. Looking for y using random.
Miss Rogers, the door. It's kind of a random question, but I was going to ask if you could text my dad in a bit just to ask when he's going to be picking me up just to do my doctor's appointment.
I'll do that later, okay?
Okay, thank you.
Uh-huh.
Sorry.
That's fine. Looking for y using random x numbers. F of x is really your y in disguise.
Under the cover of y.
Exactly. So we're going to be looking for y using a bunch of random x numbers that you come up with. Any random numbers. Because this equation is like the thumbprint for whatever your graph is. It's identification.
Why is it spot?
And all you need are a bunch of x's. No matter what x you put in here, you'll come up with a y, and all of it will fit on the line.
It's
So for example, here's my equation. Let's see, Michael, choose a random x.
3.
Okay, so I'm going to rewrite my equation, and I'm going to put 3 in place of x. And I'm going to write Michael chose 3 to be x.
what if we chose 72?
I don't care what you choose. If you choose, it says random, so any number. He chose 3. So then, Michael, what is 2 times 3
6,
plus 4?
10.
So then basically, y equals 10. So what would your ordered pair be, Cecilia? What was your x that Michael chose?
3,
And what's our y?
10.
There's our answer.
Well, is it all we're doing today?
Well, sort of.
How are you gonna check that if we all have different answers?
You'll see.
Okay.
Just go with it. But do we have any questions about this? You can move it in Joanne's, or you can move into that desk. That's your choice. Any questions about this so far? All right, let's move on. A graph may be used to determine if a relation, remember what a relation is, what is it? What does it look like?
X and Y.
That's right. If the x and y's is a function. A graph may be used to determine if a relation is a function. And remember, no duplicated x's. And it's called the vertical line test. It is not a function if two or more points lie on the same vertical line. Basically, if they have the same x. And I'm going to give you an example. You good, Izzy? All right, here we go. So I'm going to draw my Cartesian plane. This is my X and this is my Y. Okay, and I have these dots. And they're not, I put them very specifically. Yes, Taylor? Okay, hold on. So, I'll let y'all catch up. Without writing the ordered pair of these dots, okay, can you tell by just looking at this if it's a function or not?
Yeah.
Is this a function? Taylor, raise your hand. Well, you had your hand up. So, do you think it's a function?
No.
Tell me why.
Because two of the dots are on the same X.
Perfect. He's correct.
Negative 2.
No, it is not. There are two negative 2 x's. Let me show you. Right here and right here. If you notice, guys, I need everyone looking at the board and not writing. Put your pencils down. Look right here. See these two dots? If this is the x-axis, right? Both of them have an x of negative 2. This dot is negative 2 and 2. This dot is negative 2 and also negative 2. So both of them share the same x. Do y'all see that?
Yes.
Do you see that back there? Because look, if I were to draw, and the vertical line test is this, if I were to draw a vertical line, would it go through 2 or more places? Yes, it would. What about this one right here? It only goes through 1, right? And this one only goes through 1, if I were to draw a line. But this one goes through 2 dots, therefore it is not a function. Okay, y'all can finish writing. Any questions about that? Yes, Whit?
So it is a function when they're all different.
Bingo! When they're all different, when they have different x's. If they were scattered all over the place on here, but none of them had this cross the x or share the same x, then yes, it would be a function. See, I told y'all yesterday, y'all are doing better already than the Algebra 1 class did last year and the year before that. I think y'all are getting it already. Even if you're kind of shaky on this, y'all are doing pretty good. So copy this and then I'll go on to the next one. You notice math while I'm letting people catch up. It's like every once in a while it uses a different part of your brain. You know how yesterday, Emily, some of y'all were saying, this isn't like normal math. Well, it is math, but you're right. You're using a different type of math now. So it's funny how it's exercising, I guess, different parts of the brain. And what's really interesting, again, since people are still copying this down, I had, like, I'll never forget, 10 years ago, it was like my first year here, maybe 9 years ago, I had a student. He struggled through math. Just math was not his thing. And I mean, he barely passed every chapter. Then we came to the patterns, like trying to figure out patterns with numbers and stuff like that. And it was real challenging. And everyone else, even my straight A students, really struggled with it. It came natural to him. And he just flew through it. His self-esteem went through the roof because he was able to just look at it. Oh, I know what this is. And he just got patterns. So it's funny how, certain parts of your brain can do some things while in the same subject. And then others, it's like, man, I don't understand this. I just think it's kind of cool.
Is this getting near geometry?
We won't be doing geometry till later if we even get to it.
Is this getting near geometry?
This right here? Not really. Okay, now let's say I have another Cartesian plane. And
Wait, did you forget the E whenever you wrote there on 2x's? Maybe.
I did. Thank you. Okay, let's say this time, instead of all the dots, my graph looks like this. Because we're getting into non-linear type things. So let's look at this. Is this a function? That says, is this a function of very tiny letters? Okay, so look at this graph. I don't have any points on there. I just have the actual graph. Raise your hand if you want to guess. Whit?
It is not a function.
Why?
Because this is a guess, by the way, I don't know. But it could be because the arrows are ending or they're beginning and ending at the same spot.
No, that's just a coincidence.
Well, I don't know.
Michael, you have a thought on it?
Well, because they're not segments, it's a line. So
Oh, that's okay. A line, this could be a line. A function can be a line. Any other thoughts? Taylor?
Is it because since you said that each part of the line is like one singular dot and it's right below the other one, so it's
Okay. Taylor nailed it. A line is really a million little ordered pairs. Just a million little ordered pairs. And at some point, would this ordered pair up here cross at the same X as this one right here?
Yes.
Vertical line test. Can this vertical line cross my graph in two different places?
No.
Here and here. Not the Cartesian plane. I'm not talking about the Cartesian plane. I'm talking about my actual graph. If it can cross in two different places, it is not a function.
Wait, in two different places, what does that mean?
Right here. 1, 2. Look right here. Watch. I'm going to draw my vertical line test. It crossed here and here. Two places. Therefore, it is not a function.
And couldn't it also cross, like, basically all of it?
Yeah, look. See?
it can cross
No
over-
matter how many places I do it, it's crossing in two or more places. If it can cross in two or more places, it is not a function. Does that help?
Yes, ma'am.
Also, since it's a line,
A line? Well, watch this.
that down?
Yep. Is this a function? Aiden?
No.
Why not?
I mean, yes, this is, they are not crossing.
Ah, it is a function. Because look, no matter where I draw my vertical line, is it crossing my graph in more than one place?
Wait, what?
See those vertical lines? It's only crossing my graph in one place, no matter where I draw them. That none of these ordered pairs are sharing another x. Y'all see that? So a line can be a function. Look right here. Do you see here's my graph? This is my graph or my line. And notice I can cross it in two places all over the place. All it takes is one. And then right here, none of them share the same x. Do y'all see that?
Yes.
Good. Y'all get it now? All right, does everyone have it?
Oh yeah, I have the
Good.
first part. I don't understand it completely.
Oh, you'll get it. So open up your book to page 360. We're actually doing really good on time considering we had that drill. The
Silly
life-saving drill. Yes,
Can I go first?
make it quick.
Get what it is.
All right. Let's see. Open up your book to page 360. Taylor?
Get what it is.
No, you don't need to know what time it is. Smarty pants. I know some Spanish. Not a whole lot.
What's some?
I used to speak it fluently.
You did?
Oh yeah. I literally spoke it fluently because when I was growing up, my babysitter was my best friend's grandma, and she didn't speak any English.
Your babysitter was your
Best friend's grandma,
Wait.
So
Oh,
the grandma was the best.
and the
friend.
grandma
I
was
mean,
the grandma was a babysitter. So we're gonna try to give Aiden some time. So the grandma would babysit me, and she didn't speak any English. So she would turn on like soap operas that were in Spanish, and we'd watch all kinds of stuff in Spanish. And so
So you
I learned Spanish, and to the point that I could understand it and speak it fluently, all the time.
That's the avenue.
I for like years I could. I'm starting to lose it now. Every time I've gone to Mexico and everything, it starts coming back after like one day being there.
Work in Mexico.
I had like last couple summers ago, last year in February I was in Mexico, and I carried on this long conversation with my cab driver,
Really?
all in Spanish, and I couldn't believe it. I couldn't tell you what we were talking about now, but
You just remember the word.
my sister got married.
The word
We were in
name.
January.
Did you have a question?
You started recording.
Oh, I'm still recording. That's okay. Joanne can hear my story. All right, let's go ahead and get started.
She'll feel like she's
All right, so let's see. Michael, read the directions. Wake up, Michael.
Given from the sets of ordered pairs, whether the relations or functions.
So they're saying all of these down there from 1 through 6 are relations. What they want to know is, are they functions? So number 2, I'm not going to write them all down because you can see them in your book. You see the list of ordered pairs. So Michael, is that a function just by looking at it?
Yes.
Why?
Because none of them have the same x.
No same x. I'm writing this down for your notes, and you are too, but on your homework you don't need to do that. But you are writing it down as well. Cecilia, look at number 4. is that a function?
Yes. I mean, no.
Which is it?
No.
Why not?
Because they have 3 and 3 as an x-axis.
That's right. It has repeating x, which is the 3. Do y'all see that? Wit?
Why couldn't they have just said that if it does have the same, then
I don't know, because it's the rule.
I just don't. It doesn't make no sense.
Well, Wit, do number 6. Is number 6 a function?
It is not.
Very good. Because it also has what?
A repeating x.
Yeah, because that -1 has a repeating x. Good. Think y'all got it. All right, let's look at 8.
We're doing this?
Oh, yeah.
What does this mean?
Those are called circle mappings.
Are they hard?
Well, and I didn't put it in your notes because we're doing it now. So look at number 8. It says determine from the circle mappings whether the relations are
Is
functions.
the left circle an X? And the right
Bingo. So I'm going to show y'all. You're going to draw this too. All right, so Taylor was correct. The left circle are your X's. Your right circle are your Y's. So Gabby, just by looking at this, would this be a function? No. Because what this is, you see the repeating 2, the 2 is used with the -5, and the 2 is used with the -7. Let me show you what this really looks like. The ordered pairs would be 2 and -5, see we're following the arrow, 2 and -7, and then 4 and -10. So notice that's how these circles are used. The arrows tell you which number they're paired with, and you can write them down if you want,
Yeah, it's
but
right.
notice that the 2 is used twice. Do y'all all see that? So then therefore it is not a function. Whit, you have a question?
I do. So basically, if there are 2 in one circle and then 3 in one circle, then it's always not going to be a function.
No. Well, I mean, I guess, yeah. All you're looking for is if any number in the X circle is used more than once, which in this case it is. So because it has a repeating X, the 2 is used more than once, then it is not a function. All right, Emily, 10. Now I'm going to draw this out. 2 and 4 and 6, and then 3 is over here. And this is a tricky one. So Emily, and by the way, these are your answers. Didn't box them in. Emily, once you have this drawn, is this a function? She's saying yes. Why?
Because the y is the same, but not the x.
She said it perfectly. So the y is being repeated here, correct? So this would be 2 and 3, and 4 and 3, and 6 and 3. But the rule is you can't have repeating x's. Well, she's correct. The x's are not being repeated. It's okay if the y is being repeated. Good job, Emily. As long as the x's aren't. Do y'all see that? So that one was tricky, but it didn't get you. See, I'm telling you, y'all are doing so good. Any questions? Good job.
Can we do one more of those?
Sure. Let's look at 12. I won't draw it. Let's just look at it. Michaela, look at number 12.
Oh, wow.
Are any of the x's being used more than once?
No.
So then is this a function?
Yes.
You're correct. No x is being used more than once. Does that help, Whit?
Kind of.
So basically, if on the x side, if like two of them or like however many are going to the same y.
No.
Wait, what?
Look, see this? See how there's two arrows going from the same x?
Yeah, that's what I meant.
Yeah.
That
Then that means the 2 is being used more than once. See that, Whit? I'm explaining it again. See how this 2 is going to the -5 and the -7. Therefore, it's being used more than once. So it's a no.
okay.
The y can be used more than once, but the x cannot. Everyone got this? All right. Let's look at 14. Look in your book at 14. Izzy, is that a function? You can use the vertical line test, or you can even write out the ordered pairs. Are you guessing? You're correct. It is a function because none of those dots use the same x. If you were to write out the ordered pairs of number 14, are y'all looking at 14 in your book? If you were to write out the ordered pairs, it would be -3 and 2. And you, by all means, could do this. 1 and 2, 2 and 2, and 4 and 2. Do any of these x's repeat? Whit?
No, ma'am.
But how about the y's? Do they repeat?
Yes, ma'am.
But that's okay, right?
Yes, ma'am.
Okay. Also, let me see your book.
Just like yesterday.
You could also do the vertical line test. Let me try to do this. Hold on. Whoa. Okay, you could also do the vertical line test. You could draw a line through this dot, any of them. You see that? And they only cross one time. Right here, 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 and here. So they only cross the x one time. Do y'all see that? All right, let's look at 16. Cecilia, is that a function?
No.
She's correct. Good job. Why not? That's right. One of them passes each other. There's repeating x's, and I'll show you in just a minute. So 16's a no. Let me see your book. Look at 16. Are y'all looking? Look right here. See these two dots right here? If that's all right, they're sharing the same x. If I were to draw a line through them, it crosses both of them, right? They're sharing the same x. This would be 2 and 0. This one would be 2 and 1, 2, 3. This one right here would be 2 and 3. They share the same x. Do y'all see that?
Where are pages ahead of the other one?
All right, let's look at 18. Wit.
It is not a function.
Correct. It is not a function.
There's no function.
Because you can draw a line through that graph and hit it in two different places. Any questions so far? Let's do 20. All right, here we go. It says, the directions say, if you look in the directions, it says f of x equals negative 3x plus 2. Find the following. So 20 gave you f of negative 2. Do y'all see that? Do we all see that? All right. So what we're going to do is we're replacing that negative 2 into that x. This was the equation in the directions. Number 20 says f of x is negative 2. So they replaced that x with negative 2. So that tells us we're just going to replace, substitute right there. So now we have negative 3 times negative 2 plus 2. Does everyone see that?
Yes,
Good. All right, so negative 3 times negative 2 is what, Taylor?
6.
And 6 plus 2 is what?
8.
So f of x equals 8. Does that make sense? Good. 22. We have the same formula, right? The same equation that they gave us in the directions. But Michaela, what did they say the x is for 22?
4.
That's right. They said it's 4. So we're going to substitute that 4 into that x. And Michaela, what is negative 3 times 4?
Negative 12.
And then when you're done writing, what is your answer?
Negative 10.
Good job. Any questions? So y'all understand this? All right, let's look at 26. Let's see. Emily, what do the directions say?
G of x equals x over 2 negative. Wait,
Minus.
minus 3. Find the wrong.
All right, so for 26, what did they say the g of x is?
X over
No. Look at 26. Look at the number 26. What did they give you?
G times -2.
So it's g of -2. So they're basically saying replace that -2, or replace the x right here with -2. Do y'all see that? All right, so I'm going to replace it. I have -2 over 2 minus 3. Do y'all see that?
Yes.
So Emily, what is -2 divided by +2? You're correct, -1. So -1 minus 3, what do you get? Yes, ma'am. There you go. Any questions? I got one more for you. Y'all have this written down? And then I'm setting you free. Y'all got it? Cecilia, you got it? Emily, you got it? All right. Last one. 38. Boy, I'm challenging y'all today. Okay, 38. Gabby, what is the directions?
Find the range of the following functions if their domain is -3, 2, and 5.
Okay, so they're asking to find the range. What's the range again?
The Y.
Bingo. They're asking you to find the y. And they gave you the domain. And what's domain again?
X.
That's right. They gave it to you, and it's -3, 2, and 5. And you're correct. It's the x. So they gave you the x. They're asking for the y. So 38, Gabby, the equation is g of x equals -x minus 1. So in this case, I'm going to make a chart because Whit said yesterday he likes that table.
Periodic table.
And I'm going to go ahead and I'm going to put my equation on the top. And this is going to be my domain, which is really, it's g of x. Okay, so Gabby, my x's are what? Tell me what to put over here. Very good. So we're taking these x's and we are placing them in the x column. Now here's tricky. Look right here. Do you see this -x right here? We're going to replace or substitute that -3 in there, so it's going to look like this. Do y'all see that? This
I'm
is a
still
negative.
writing stuff.
This is a negative x, and we're replacing a -3 in there, so it's going to look like this. Okay, so Gabby, what is -3? And what's +3 minus 1? Very good. So I'm going to go ahead and substitute my next one. Gabby, this is a -2, right? So what's -2 and -1? Very good. And then this is -5 minus 1. What'd you get? And then what they want is it to be written like this. So now you have your answers. They're asking what the range is. So we could write them in order of pairs, because this is what they'd look like. But all they're asking for is your range. And you're writing them from least to greatest. So it would be -6, -3, and 2.
Can we do just ordered pairs? No.
We have to follow directions. So least to greatest. All right, so y'all are going to be doing page 360 to 361. You're going to be doing numbers 1 through 17 odd. 19 and 21.
So 1 through 21.
25, what is that? 25, 27, 37, 39. This is going to be due Monday. You have IXL due Wednesday. And you have a quiz Wednesday.
So it's going through 21 on.
Whatever. It's written there.